Okay, so let's take a look at assignment 2. You were asked to read the case of Vanessa Culver and then identify how she implemented each of the effective teaching practices. The first effective practice is establishing mathematics goals to focus learning. Ms. Culver's learning goal was that she wanted her students to understand that exponential functions grow by equal factors over equal intervals, and that in the general equation y equals b to the exponent x tells you how many times to use base b as a factor. She also wanted students to see the different ways that the function could be represented and connected. Ms. Culver wants her students to have a conceptual understanding of exponential relationships. She wants to build their procedural fluency from that understanding. And she wants her students to also understand the connections between the different representations of exponential functions. So Ms. Culver used a task that promotes reasoning and problem solving. That's our second effective practice. The task she chose to use was the pay it forward task. And she implemented this task prior to teaching her students anything about exponential functions. They did not even know the definition of that at this point. So let's read the task. This task says, in the movie Pay It Forward, a student, Trevor, comes up with an idea that he thought could change the world. He decides to do a good deed for 3 people, and then each of the 3 people would do a good deed for 3 more people, and so on. He believed that before long there would be good deeds happening to billions of people. At stage 1 of the process, Trevor completes 3 good deeds. How does the number of good deeds grow from stage to stage? How many good deeds would be completed at stage 5? Describe a function that would model the pay it forward process at any stage. The pay it forward task engages students in exploring exponential relationships. The task does not require students to use any particular procedure, so they can use whatever makes sense to them. And hopefully from these strategies that they use to answer the first 2 questions, they can come up with the function. And something else that's important to note here. Every student should be able to do something to solve the task, even if it's just a tree diagram of stick figures. Let's take a look at the different solutions Ms. Culver's class came up with. Group 1 had a misconception, and they wrote the function as y equals 3 times x. Group 2 started out with a table like group 6 and 7 and came up with the function y equals 3 to the x power. Group 3 started out with a tree diagram and ended up with a table. Group 5 started out with a table and found the graph. So we see the variety of solution strategies that students use to solve this task, from the least sophisticated to the most sophisticated. That's a hard word to say. So now let's take a look at how she used the effective practices to support the learning of her students. So to start with, she had her students work in small groups. She provided her students resources in order to solve the problem. Graph paper, chart paper, colored pencils, markers, rulers, graphing calculators. And as students were working, she was walking around the room monitoring what they were saying and what they were doing. She was listening in to what their conversations were about. And she took that as an opportunity to pose purposeful questions. How did you get that? How do the number of good deeds increase at each stage? How did you know? And she supported productive struggle. She never told students how to do the problem. And when students struggled, She pointed them to try to visually represent what was going on in the problem and then see if they could find the pattern. But something else she did, as she was going around the room, she made note of the strategies that students were using so she could decide what groups she wanted to present and the order they were going to present. And she expected her students to be able to explain and defend their reasoning in front of the class. Now let's look at what she did in the whole class discussion. She used purposeful questions not only to elicit student thinking, but also to generate mathematical discourse. She starts the whole class discussion by asking, so who thinks that the equation y equals 3 times x best models the situation? And who thinks that the equation y equals 3 to the x best models the situation? Can someone explain why? This generated mathematical discussion among her students. And if you notice, not once during this discussion did she take over the conversation. She continued to use purposeful questions to generate that discussion. And she also used purposeful questions to help students see the relationships between the different solution strategies they had come up with, starting in this area. And it wasn't until the end of the discussion that she told students what exponential functions were. And at the end of the lesson, she asked students to explain what the relationship was between the diagram, the table, the graph, the equation, and the context of the problem. That would give her insight into what individual students actually understood at the end of the lesson. This case demonstrated how to implement the 8 effective mathematics teaching practices.